We will move on to our next session, which is incredibly interesting and a very hot topic that we're seeing today as we see more and more companies not only moving to the cloud, there's some complexity and benefit to multi-cloud deployments, especially as you think about AWS, Azure, GCP. It certainly gives you lots of benefits, but it also it also creates new challenges that you otherwise wouldn't have thought of before. And so we have the good fortune of Lily Lee, who is the manager of global strategists at Splunk, and Amit Singh from the BigGlass products team to help share some perspectives on how you might get better visibility, as well as how you might be able to take action on it. Lily, Amit, I'll hand the ball over to you.
Great, thanks. Hello, everyone. Can everyone hear me loud and clear, I assume?
Yes, Lily, we can hear you,
Okay,
and
great.
we can
And
see your screen as well.
see me and the screen. I'm showing the right screen, right? This is always
That's right.
the the challenge of virtual presentations these
That's
days.
right.
We're sharing the right things in our desktops. So wonderful.
Yeah.
Thank you for that lovely introduction. Shall we get started, or do we want to give folks a few minutes to switch out, or
I think we can go ahead and get started.
okay?
I'm seeing a lot of folks who have kind of stayed on, so I think we're in good time.
Okay, fantastic. Wonderful. Thank you. So, the obligatory disclaimer, just in case blanket security, in case we mention any forward-looking statements about products and about features, just keep that in mind as we're talking and having this discussion here today. So, let's get started. Okay, so we'll start with a little bit of overview, some statistics around the cloud. I apologize if some of this is very kind of, I guess, rudimentary, but we just want to make sure we're setting the same stage and everyone's on the same page here, right? So businesses are moving to the cloud in massive numbers, and I'm sure you've heard of this all day this morning as well. And they're moving for various reasons, but the main reasons include things like cost cutting and increasing speed and agility, as well as digital transformation for better value delivery and customer engagement. With 94% of enterprises already using a cloud service, by all odds, you are already in the cloud to some degree, even if you don't know it. The other difficulty is that for whatever reason, so many of us are using at least 3 to 5 different cloud platforms, which of course creates this massive complexity, and especially for security. So, this flexibility and scalability of the public cloud is very attractive. But for those same reasons, they also produce some of the biggest challenges. So, I'm helping my customers ask these questions, right? How do I keep up with what's running and where it's running when the environment underneath is constantly changing? Then, with siloed cloud vendor tools, how do I get visibility between my own data centers and then my workloads that are running in these public clouds and have that single ecosystem? And with more and more endpoints, especially now with the work from home climate, there's a lot more data in flight, in transit, more network boundaries, the edge is blurred, right? How do I secure all of this activity? Then, in addition to the myriad of SaaS or software as a service offerings out there, you've got platform as a service and infrastructure as a service. There's large scale adoption across various providers. Now, this might be a little bit out of date, but earlier this year, this was published and shows that, well, this is the current adoption of the bigger clouds, right? Like AWS, Azure, and Google Cloud. So, in all likelihood, you're using more than one of these providers here, which is that complexity that I mentioned previously. And then this is what makes that monitoring management hard because we need that mesh across all the different cloud providers. And so, with migrating to the cloud, as I've mentioned already, comes with plenty of challenges, especially when it comes to maintaining visibility and avoiding downtime and profiling your applications and performance. So, let's just take a moment to look at these three providers here. Every provider mentioned here has their own set of technologies, features, and security items. With the sprawl of different services, the options that you have for configuration, the different portal interfaces, and then every time I log into one of these portals, I see more services, right? So the interfaces, the services are growing rapidly, and the challenge to keep up with each of these disparate services and running them and operating them securely is very daunting. And then AWS, Azure, and Google Cloud provide many similar offerings, but they may call them by different names, or there are slight nuances when it comes to configuring and securing them. So whether you're dealing with identity and access management or something like running Kubernetes clusters across these different platforms, take for example, it's EKS for Elastic Kubernetes Service on AWS, but then you have GKE for Google Kubernetes Engine on GCP, and then AKS for Azure Kubernetes Service on Azure. These subtle differences highlight that challenge of ensuring things are set up and operating correctly and securely. Furthermore, each cloud vendor has their own native cloud monitoring tools to help you maintain visibility to your systems, your infrastructure, and your applications, etc. But ultimately, it's up to you and your organization to assemble those tools into a specific monitoring package and verify that the metrics that you're receiving and have gathered are accurate. So these three examples here provide access to performance and health metrics, for example. But beyond performance monitoring, there are services that provide account and event history. Well, then you have access logs, then you have network communications, tracing and debugging of your applications, and more. And then on top of that, in reality, most organizations actually still rely on on-premises software and applications to conduct their business operations while moving various workloads to a public cloud for flexibility, scalability, and agility. So it's essential to have a monitoring solution that empowers you to monitor your entire infrastructure, the old as well as the new, and integrate that well with the other tool sets inside your security monitoring ecosystem. Now let's talk about the various responsibility models surrounding cloud security. I presume many of you have seen this matrix before, but again, just to rehash how important it is about the shared responsibility model for security in the cloud. And each cloud provider, right, has security varying depending on the type of service that you subscribe to. So at a high level, for example, infrastructure as a service, that's the physical infrastructure, the network interfaces, the compute, the hypervisors, right? The customer is responsible for securing and managing the virtual network, the virtual machines themselves, the operating systems, the middleware, the applications, as well as the user access controls and the data that lives on them. For platform as a service, that's where the provider takes on more responsibilities. But the customer still is responsible for the applications that run on top of those. And then yet again, the access control to that platform as well as the data that lives on that platform at rest or transit. And then software as a service, the customer's responsibility is reduced, but it's still the security of the user access and data is still prevalent. And so again, that shared responsibility is different with each provider and each service type, but it's that point that's being driven home is that it is a shared responsibility. So don't forget to review their documentation on who's responsible for what, how do you properly configure things, vet the default configuration settings to make sure that it meets the risk tolerance of your organization. And so go back to each of their security models and review those. So while the public cloud vendors take these steps to ensure security of the cloud, and it is constantly improving, but just like with an on-premises data center, it's the enterprise and the application owner that is ultimately responsible for security in the cloud and for ensuring that your customers' data is secure, your workloads are secure, right? Even though your cloud service provider is offering all of these options to help the security in the cloud, again, it's still up to you, the customer, to subscribe to the relevant services that you need. Pay for them, of course, and then successfully operate them. You are ultimately responsible for how the service is utilized, including managing the access controls and the data, ensuring the proper encryption, the proper storage of that data, and then overall threat analysis and defense. The security of the applications and making sure they're going through rigorous security testing, right? And then where is that content and data stored? And then making sure, of course, the employees have awareness on cloud security best practices, just like you would with your corporate assets, for example, or any other sensitive data that you might have in your environment. And as cloud business models and security tactics evolve, it is important to also note the threats and the risks and the vulnerabilities that come with it. This report is from the Cloud Security Alliance Top Threats report earlier this year, and they called out 11 threats specific to cloud computing, which is enumerated here. But what I'd like to call out specifically is that some of the more traditional cloud security issues that fall under the responsibility of your cloud service providers, have kind of dropped in ranking because if you look at the ones that are in bold, it's evident by those 5 of these 11 threats that they're kind of higher up on the technology stack and actually require more of a managerial or management and leadership decision, which is pretty interesting, so that the experience of traditional security approaches aren't necessarily applicable here anymore, right? Because these issues that are highlighted in bold are inherently specific to the cloud. And as you're thinking about your security operations and what that platform looks like, according to Gartner, these 5 capabilities are imperative for any business looking to secure their cloud operations, right? So first off, the platform should be able to retrieve and then act upon that data near instantly, because adversaries aren't static. And so in this modern cloud environment that's moving so fast, right, and is interconnected with microservices and serverless functions, it is possible that they'll be able to laterally move across many of these components with relative ease. Then you have to pull in user and entity context, or simply any context for additional enrichment on that data, especially when you start looking across environments, especially hybrid environments. So is it normal, for example, for a particular user to create instances in that GCP account? Or is it a particular set of serverless functions that are being accessed that isn't normally accessed? Or what's actually considered normal, right? You have to profiling this, and then it can be hard to tell after a while, so you want to have good baselines, right? So, and in the middle, we talk about the ease of deploying a system and maintaining the platform. With typical InfoSec staffing challenges and skill sets, Gartner suggests that you need a vendor that's going to provide you with prescriptive capabilities so that you can quickly enable detections and analytics that are tried and true. Now, of course, you also want to be able to leverage external threat and environmental data. Maybe you subscribe to your own threat intelligence feeds. And so even security services like AWS Guard Duty or Security Hub can provide you with very relevant adversarial data from each of the cloud providers' own expert analysts so that they can help you prioritize your alerts. But then, speaking of prioritization, you then need a system that will provide you the proper support for your workflows for incident response. and then allowing your analysts to then seamlessly investigate potential threats from end to end, and then decide which are important enough to focus on immediately and which to escalate, and then which are likely going to be your false positives. So now, of course, the reason why I'm here is to talk more about BigGlass and Splunk and how together we can help you fulfill your end of the bargain when it comes to that shared responsibility model. So that was kind of the quick cloud overview. And because my wardrobe is paid for by Splunk, I will talk a little bit about Splunk. So cloud vendors don't always have access to all the information a security team would need. Say, for example, a company wants to ensure that employees log into their SaaS services from secure devices, protected with passwords and antivirus, right? But typically that SaaS provider is looking at just the users that are logged in and don't really have visibility to the endpoint itself or to the device and whether that device was actually secure or not, or on a secured network. So then the organization might leverage a cloud access security broker or CASB like BigGlass to help watch out for these types of security policy violations and then provide alerts for instant visibility of these emerging threats. So you've heard throughout the morning and through the panel the benefits of the BitGlass platform. Together with Splunk SIM and SOAR capabilities, organizations gain a unified view of their IT and security ecosystems, can validate, then enrich and contextualize, and then help prioritize the alerts, help reduce time to detect, streamline those investigations, put in those standard operating procedures and runbooks, and then help you respond more rapidly. Security analysts have that ability to receive actionable visibility and then extend consistent security to all the enterprise resources. From a single control point or a single unified view, security teams can then configure the policies that are necessary to secure SaaS applications, control access to the web destinations, identify shadow IT, or defend on-premises applications. Amit will actually go into more detail about enhancing visibility with BitGlass and Splunk.
Thank you, Lily. If you could move to the next slide, Lily, thanks. So jumping right in, BitGlass provides apps that integrate with the Splunk SIM and SOAR platforms. What you see here is your managed and unmanaged devices accessing apps and websites. And for any activity that occurs, a log is generated, and the log is generated and is categorized by types. For example, when you log into your O365 account, a log with all the necessary details is generated and can be accessed by pulling the admin type of log. Similarly, proxy logs are available as part of the access type logs. API logs are available as part of Cloud Audit, and your URL filtering and other logs are available as part of the SWG logs. So we provide a REST API interface to pull all these logs into SIM platforms. BitGlass Splunk app specifically pulls all these logs from your BitGlass tenant and then provides multiple widgets to visualize these logs. And obviously we will see some of these widgets. I have one small widget right here in the deck, but you'll actually see the widgets in a follow-up demo section that I have. So in summary, a user action has occurred, a log event is generated. These logs are pulled and visualized in the Splunk SIM platform. Now let's look at what can be done besides actually capturing these logs and visualizing them. So next slide, please, Lily. Thanks. As mentioned before, BigGlass has an app for the Splunk SOAR platform as well, and that can take actions using a logic that can be automated with what is called as a playbook. Okay, so for example, an event data is generated for a user uploading a malware file. This is logged in to the Splunk SOAR platform, and then using what is called as a playbook with BitGlass app actions in combination, the app would make a REST API call to BitGlass and, for example, place the user into a risky user group because let's say he's downloaded a malware one time or 10 times, that places him in a risky user group. This group could then have policies associated with it. For example, some of those policies you see on the right-hand side. So we could disable login for critical apps. So we could make sure that you can access maybe most things, but maybe not Salesforce, maybe not Office 365. You could allow access from only known locations, from your Office VPNs. Or you could block upload and download capabilities, so they can go ahead and view their emails maybe, but maybe not go ahead and actually upload any attachments to or download any specific files which may have confidential data. And this is the specific use case that we will see addressed in the demo as well. Next slide, please, Lily. Thank you. So here we address how multiple security tools that integrate with Splunk could detect and provide the source data for the actions. So in the first slide, we talked about how data that is coming from BigGlass itself could be the source data, will be the source data and actually go ahead and take actions. But the key integration part would come in where you could actually take in source data from multiple different integrations that Splunk already has. So for example, a user could get a malware file from a shared USB device, Silence could detect it, log the event, and a playbook could then be used to proactively force one of the security measures we discussed in the previous slide. And then again, depending on the level of automation you require and you want to have, you could even remove the user from this risky user group once remedial measures are taken. And depending on, again, the level of automation, this could be automated with a ticket management system like Snow in combination with another playbook, which then removes the user within BitGlass from this risky user group once remedial actions are taken. So I've talked through some slides. Now let's look at a demo of what we just talked about. In the interest of time, I have a pre-recorded demo, which has been sped up in certain sections to keep the demo within the allotted time frame. Lily, if you could go ahead and play the demo, and thank you again for moving the slides. Thank you. There should be audio. Lily, I think you're on mute. That's why your audio. If you could restart the video and then.
Okay, sorry about that. Let me try that again.
We see the BitGlass Splunk SIM app is already installed and configured. Data is visualized for the 4 tabs. In this section, we chart DLP patterns, matched, and file details. And in this section, we visualize user activity over different time periods and overall usage. In the application analysis tab, we visualize the patterns in which users are using the application and activity. And in action analysis, we focus and highlight user and app actions. With that said, now let's look at the Splunk SOAR platform. We have an app which supports multiple actions. As part of this demo, we will specifically be looking at a user being added into a risky user group. So here we have the BitGlass management portal, and I am on the Google Apps policy section. I'll highlight the specific DLP pattern we'll be using as part of this demo. It's the malware advanced scan pattern. We have a block action and an inline notification also turned on. Now we go to the Google app and try and upload a malware file. As you can see, I've failed to upload a malware file and an inline alert is displayed. Now let's look at the logs generated for this event in the BitGlass management portal. As you can see, a log is generated for the same file name. You can go ahead and search and see and find the same log with the same file name and user present also in Splunk. Now we've already configured a Splunk Phantom app, which is connected to a Phantom SOAR instance. As you can see, the connectivity is active. Now we go into the Phantom SOAR instance. As you can see in the artifacts page, the Ceph log entries are present. And here is the playbook, which identifies if a file type is malware. It will go ahead and place that specific user to a risky user group. Let's look at the details. As you can see, we derive the username, which is the email address, and file type information. Then I have an if condition where we see if the file type is malware advanced or not. If it's not, nothing occurs. If it is, we go ahead and take an action after user justification to go ahead and add the user to a risky user group. Okay, so you will, in the playbook itself, you will specify the specific group name. The username is automatically derived from the log entry itself, and then the action is taken. Now we can jump back to the BigGlass management portal and see the risky user group already has the specific user that we uploaded the malware from. Okay, so now I have also created a policy for risky users groups, which basically forces anybody that belongs to risky user groups to not be able to upload or download any files onto the Google app. Now I'll go back to Google and try and upload a file. As you can see, an inline alert is generated and the file upload is blocked. Now let's go ahead and actually give it a try for file downloads as well. So I'll go ahead and try and download this PDF file. And as you can see on the bottom left corner, that we've been blocked from accessing the file. Thank you.
Lily, Amit, thank you so much for those perspectives, and also Amit for that demo. We do have a couple of questions on the line. I'm just going to make my way backwards through them. The first one is from Mara. She says her question is, I guess from this last example, we've given BitGlass as an example of an action that can be taken at the end of a workflow. Are there other good examples of actions that you typically see from customers? So I guess, and whether it's BitGlass or whether, Lily, you probably actually see a pretty broad spectrum of potential actions there. So I'll leave each of you, maybe Lily, if you could go first, and Amit, in case you have other thoughts there as well.
Sure. When it comes to automating actions or orchestrating response for incident response, there's a lot of actions that can be taken, and that could start with everything from like gathering more information, contextual information, enriching the data set that you have. For example, you have a file hash or a process name. You have some sort of, you want to go out to, let's say, open source and Intel, or you have something like a service like VirusTotal where you're going to query that hash. That could be an example of an action. Another one could be internal action, like if you need to look up an employee's details and you need to enrich that information back into your event data, some of that action can happen automatically as well as changing configurations, such as in the BigGlass example, right? The policy changes, but this can extend to things like firewalls as well. It could extend to any edge border type security, or maybe not even that much. It could even be an application layer access control that you're changing. Anything pretty much that you can talk to over an API, you can pretty much action it. Action. Yeah, I don't know how to verbify action, but pretty much you can action it. I hope that helps answer the question, Mara. But then other actions could also include human intervention. Like, I want to get Kevin's input on this, so I'm going to actually prompt him to review, then respond before any subsequent actions can ensue, right? So there's a lot of examples, and I'm happy to connect with you directly if you have something more specific or a specific use case that you'd like to discuss. Hopefully that was helpful.
Yep. And Amit, your thoughts as well?
Yeah, so from a BigGlass perspective, the way the framework of the way we've implemented this is the action that you perform would be using user groups, adding users to certain user groups. And then based on that, everything that you can do on the policy page could become an action. So few of the examples I gave was an action could be um, user is forced for two-factor authentication. The example that was shown in the demo was the user is placed into a risky user group where he's denied access to upload and download functions, right? So the way the framework of way that we've implemented is that anything that you could do with the BigGlass platform in terms of policies, you could go ahead and then become an action, because it's based on something that is common, which is basically placing a user into a group. Okay. And again, in terms of more generic, you could even, I think I briefly mentioned it, you could even take remedial measures. You could tie it if your ticket management system actually generates logs. Once your ticket is resolved, as part of that workflow, I didn't have it, but you could add an automated ticket management system generation that opens a ticket. Once that ticket is resolved, then the action could be then go back and actually migrate the user out of this risky user group, so he can then go ahead and access, but he still has read-only access till then. And then once he's migrated out of the group, based on speaking to him, figuring it out, updating the latest virus engine patches or whatever. So there are a bunch of actions that can be taken. And again, it's driven by the user and group management policies that we can create using using a REST API call.
Wonderful. Thanks for the both of you for that. We have two final or other questions. I'll stay on you for this first or second one, depending on perspective. Amit, there's a question about the Phantom app and whether it costs anything.
Obviously, if you have the BigGlass services, it's not yet available. It's a roadmap item that should be available, hopefully by the end of the month. And that's why we had the roadmap disclaimer slide at the first deck. But yes, it's not a paid app. It's something that you can download as long as you have the Splunk platform available, as well as BigGlass services. It's not a paid app. It can be downloaded once available. The Splunk app is already available. It can be downloaded. It's certified for Splunk Enterprise as well as cloud instances. So that is also available, again, free. If it's not a paid app, it can be downloaded directly from the Splunk app-based portal itself.
Great, wonderful. And then Lily, the final question is for you. The question was asked kind of on that slide where you showed the different inputs that would go into Splunk. It's a matter of a question on prioritization. There's a lot that can go into Splunk, of course. So if somebody is just starting to try and build out visibility across these cloud footprints, are there, assuming all inputs are not created equal in some sense, or some might be easier to first get access to, are there, I'll sort of reframe the question for the person who asked it, are there some quote unquote easy wins or easy places to get visibility, or some data sources that you might prioritize when thinking about getting that input into your SIM?
Wonderful question. I would want to say it's actually maybe two separate things. I always advise our customers, the first thing that they should do is step back and look at what is it that they're protecting. Of course, I'm inclined to say all data is security relevant, because frankly, all data is security relevant, but that's not realistic and it's not prudent, right? So what I would say is whiteboard your crown jewels. What is it that you're protecting? Is it data? Is it customer information? I mean, obviously there's a lot of PII that floats out there today, but where is that stuff housed? And then how do you access it and put on your adversarial hat and imagine if you were navigating through the environment trying to get to that crown jewel, what is the path of the data that would be taken? And that's where I would start, is doing that reverse engineer of my crown jewel sit over here in this Azure blob, for example, right? Like, then from there, what are all the different services that touch it? And then how do I get visibility to things like event history against those services, or to logins to the server, or access to that exact asset, right? And what was that asset that was touched? So that's what I would do from a prioritization standpoint. Now, with regards to quick wins, I would say that definitely in all the different cloud providers, the most important things are things going to be like account activity history. That gives you a lot of visibility into threats like anomalous logins, brute force, also things like resources that are being spun up kind of unbeknownst to you if someone was trying to DDoS you or run up your bill, for example, right? Those anomalies are very evident in things like audit trails and account activity history. I would also say access to the services themselves, like audit trails of, like for example, in the AWS world, you've got access to your APIs. Who's accessing them? What's being touched? What user agent? Is it a bot? Is it a human being? And geographical location. All that are really quick wins around some of the more common or basic anomalous adversarial behaviors, and then frequency, right? Because you can time things, especially if you have a time series indexer. It's really helpful to chart the timing of all of this access, so you start to see examples of clusters of activities. Is it slow and low? That kind of idea. Does that help, Kev? Did you? I don't know who asked the question, but hopefully that helps answer kind of the two tangents I would take. But if you just want to get started right away, definitely access trails that have event history and account activity, as well as service access. Those are definitely the very key important things to start with, especially if you also want to know, hey, I don't have that. I didn't think I had that service enabled. How come it's being utilized, right? So
wonderful. Well, Lily, Amit, thank you so much for your time today, your inputs and your thoughts and approaches.